name is Mitchell Gumko. This is week 5 for geology, and this week we got to do a little experiment for the video. And we did like experiment to see all the different type of rock formations and how they change and stuff like that. It was really cool to just basically go through the rock cycle, and it was really fun. And I had a great time doing it. And I actually did it with one of my group partners in my group, Grant Martin. We did it together at his apartment. So we did the starburst experiment. So what we did is we took pieces of Starburst, just like the candy, cut it up, and put them all into different bowls. We used red and orange, and we cut them up, and we put them into different bowls, and then we put them together. So like the beginning part, those were our sediments. Obviously, once we cut them up, separated them, then we put the sediments together. We pushed them a little bit together to make the cementation and the lithification process of the rock and sedimentary rock process. So then they became together. They weren't fully compressed, because it's still like a sedimentary rock. So we did that, and then that gave us our sedimentary rock, which is very cool to see. Very it was a good time. And then we put that piece of rock, we put it on a piece of tin foil, and then we put it on top of a stove. And we melted it a little bit to change, the heat, just how a metamorphic rock, either you can change the heat or the pressure. So we chose to change the heat in this situation. To melt it down a little bit, we let it cool, we took it back out, and then you could see the metamorphic rock. And then for our final part of the project, we took the rock, we put it back on the stove, or the piece of starburst, I should say, put it back on the stove to make this part of igneous rock. So we took it, put it back on the stove, it melted it again, melted it all the way down. Then we put it right into the freezer so then it could freeze, get really, cool really fast, like sometimes igneous rocks do. And then we pulled it back out. That one was a little bit more difficult. Kind of messed up a little bit. We kind of heated it up too fast, so then it kind of burnt, and it wasn't as good as it should be, and it crumbled. But you still kind of are able to see what the igneous rock looked like on the tinfoil. We weren't actually able to pull it off because when we start to pull off, it broke apart. So then what we actually ended up doing to complete the rock cycle and restart it, we pulled off all the pieces, put them into a little bowl so it's like the sediments again, and then you could restart the process by pushing it all together. So that's what we did for our experiment. It was, like I said, it was very fun, very interesting, and I think it was it's realistic to a degree. It's not going to be as realistic as it can be. The metamorphic part of this project is really hard to do because changing heat and pressure with your hand or the stove can be, especially let's say you're doing with the stove like we did, melting it down. That's very similar to how it's going to be when it turns into an igneous rock. You got to be kind of creative with the way you do it. So that's why we were like, okay, we'll melt it down a little bit, not like fully get it all like oozing and like oozing, you'll see what it looks like, but like we'll get it, pretty well melted down so it changes a little bit of its texture and the way the rock is, and then we'll let it cool, pull it out, and show what it compared, like how it changed from a sedimentary rock to a metamorphic rock. And then the igneous part, like I said, we kind of ruined it, kind of melted it too much, so then it burnt, and then that happened, and we put it in the freezer though, so then it became kind of really like glossy texture and cooled really fast, how sometimes igneous rocks do. So that was really cool. I think doing these types of projects are actually really nice because when you do something like this, it makes like something that can be kind of hard and like more difficult to understand than it has to be, like the rock cycle, very simple. You can see it, like I'm a visual learner, so I can see it very easily when I did this. And when you do this, like you really can iron out and like see how simple it actually is without like, you read it in the text and it can be confusing. But like you do the experiment, you see actually what happens. You go step by step, and you can actually see how the rock cycle works on a smaller scale. Like I said, it's not fully realistic, obviously, because we did this all in a matter of a couple hours, right? Where the rock cycle takes many years, centuries, decades, whatever. It takes a long, long time. Where this, since it's a small scale, you can do it really quick. And I mean, like I said, the metamorphic rock was kind of a hard part to do because I felt like when I was doing it, I was just making an igneous rock because, oh, I'm just melting it down. But I mean, yes, the metamorphic rock can change with pressure and heat. And then when we were making the sedimentary rock, that was kind of hard too because you're pushing all the sediments together. So then you're like, oh, I'm kind of changing the pressure of this, but they're just sediments and not like a sedimentary rock yet. So that's how it was. But I think It's actually a really good way to make things more simple. This is such a simple project, which makes the harder stuff that you actually learn in class turn out to be very simple. And I really enjoyed doing this.